Right, so this is my Stirling engine. I made this in Fusion 360, which is made by Autodesk. So I started out with making a list of components that I needed. I decided that the main things I needed were a base, uh, a support for the pistons, uh, the two pistons, the wheels and their holders, then the two links to connect the flywheel and the pistons, then pins to fit in all the holes. So these right here and these right here. This was a candle I made just by two simple extrusions, just for decorative purposes. So I made each one of these pieces individually, so then I could easily individually export them and print them. And then I used the joint operation that allowed me to connect the pieces. After that, I animated each of the pieces and linked together the motion, so that when I turned this wheel, the entire system moves. A real Stirling engine works by cyclically heating and cooling air. There are two pistons, a hot piston and a cold piston. The hot piston is heated up by some outside source, and the cold piston is cooled down by some outside source. A tube connects the two, and when the hot piston heats up air inside the tube, it will expand, pushing the piston in and letting air travel to the cold piston. Cold piston would then initially push in, and when the air cools down enough, it will pull the piston back out, and the air will travel back through the tube until it goes to the other piston. And this piston is heated up again, and the cycle repeats. This cyclical heating and cooling causes the wheel to turn. Instead of just making a Stirling engine, I also added on a mechanism that functions similarly to a conveyor belt. If it was a real Stirling engine, the flywheel turning would cause the other wheel to move because a belt will connect the two. However, in this model, I placed a peg on the secondary wheel so that turning the secondary wheel with the peg will cause the flywheel to move. The entire design was 3D printed. Each piece was printed separately, so you have the holder and the wheels and the pistons. They're all printed separately, and then I just put them together once they're done. So this S-shaped support here, this is glued using super glue directly down the base plate. And I did the same exact thing with these wheel holders right here. I found out that it made the most sense to do it because otherwise it wasn't very stable. After that, I glued on the pegs you see right here onto these wheels. And once they were set, I drilled a hole into the side of the peg and then ran a cotter pin through, which held it on the best. Then I used the same sort of cotter pin on this link right here, or these two links. And I originally was going to use pegs, but instead I opted for using screws. I believe there are 3/16 inch screws because they just held on to the frame much better. I'll also throw a rubber band on here to make sure that twisting this or turning this will work. And now you see that by moving this, the pistons move and the entire operation works.